Welcome to our YouTube channel. This is Murli Dhulam. Today's video, let us discuss about on-premises Kubernetes environment. So here we onboarded Kubernetes master node as well as worker node. So with the help of kube-adm, we onboarded one of the master node here, and also second one is Kubernetes worker node. And also we used pod network called Calico pod network. And also here, let us try to identify, these are all layers, master node layers. So whenever is there any user is trying to execute any instruction will be sent it to API server, from there etcd and scheduler control manager. Let us see all these layers also. First, let us observe all these layers within the server also. You see, this is the Kubernetes master node. This is our Kubernetes master node. So by default, there is a service. So within the default namespace, there is a service. Okay. So there's a service you can see. And now also let us observe within the master node, whatever layers we are seeing or components, important components, API server, etcd, scheduler, control manager, these all things will be reside in kube-system. Right? So you can see that scenarios also just see. So here we need to use all these scenarios, kubectl get all -n kube-system. Namespaces, same concepts we already discussed in the Docker. You see, let's go back to Docker. This is a Docker server. Within the Docker server, so two terms you can see that. One is control groups, other one is namespace. Namespace refers to isolation. Isolation between different containers. Similar way, control groups, it refers limits. How to limit your resources, container resources. Right? Same concept we are extending in the Kubernetes also. Okay, so this one you can see these are all components placed in the kube-system namespace. And also whatever containers you are deploying, by default those are all containers or pods will be deployed into a default namespace. Right? These are all system related pods you can see. So we onboarded our pod network. So this is the pod network. You see, these are all pod network related pods. Right? So also our core DNS related pods. One by one means one pod, one container. Right? And also just see etcd, API server, control manager, scheduler, proxy. These are all things you can see. These are all system related pods you can see. So whenever you are trying to send any request will be received through API server. Then it will send it to etcd. etcd is a database. It is trying to maintain entire database related to cluster information in terms of secrets as well as desired configuration state. These all things will be stored here. And scheduler, it will try to decide like where we can place your pods or containers. Suppose if you are trying to maintain multiple pods, multiple worker nodes, where you are going to place your containers or pods, scheduler will decide. And control manager, it will maintain desired configuration state. Okay. So in this way, these all things will be processed at master node. Once it is done, your pods will be onboarded to your worker node. Okay. So here we onboarded one of the pod, like a simple pod here we onboarded. Let me show you that pod. So one of the Nginx pod here we onboarded, which is in the default namespace. Okay. So here I mentioned kubectl get all. Without mentioning any namespace, it is showing Nginx pod. But if you need system related pods, just use kubectl get all -n kube-system. Right? And also just see other components also. So here it is using our system related pods. They used deployments, replica sets, daemon set, and other components as well. So we are going to discuss all these points coming videos. And also let us see. Next, let us go back to prerequisites as well. Whenever you're trying to set up your Kubernetes, so these are all in terms of networking. Control plane, worker node, nothing but master node as well as worker node. You can call master node or control plane. So these are all prerequisites you see. Control plane prerequisites. Similar way, worker node prerequisites also there. And also just see, these are all port numbers you can see. Right? These are all port numbers you need to see. Just see these scenarios. API server, etcd, kubelet, scheduler, control manager, same points, right? We are discussing same points only. So these are all port numbers you should open. and also how to add this worker node with our master node. So if you observe Docker, there is a Docker bridge. Okay. So for networking, we are using Docker bridge. For same scenario here, you can see our pod network. Pod network, you can start using multiple networks. Calico, Flannel, right? Different networks are there. So here I'm using Calico pod network, right? So here we added Calico pod network, right? And also next, let us see other scenarios like, okay. So example, we are trying to onboard our Blinkit application. So for all this Blinkit, so our Kubernetes engineer developers are developing microservices. We are trying to onboard these scenarios in the worker node. So if you are trying to add your worker node with master node, so here two options you see. Just go back to this command while adding your clusters into Kubernetes. You see here two options are there. So one is, suppose if you are trying to add more number of master nodes. Why we need more number of master nodes? High availability. For a master node, high availability. If this master node goes down, just imagine Blinkit, it contains around 40 microservices. They're all 40 microservices we deployed with multiple worker nodes. So here we deployed with multiple worker nodes. If anything goes wrong with our master node, we may end up with big issues. Instead of that, you can start onboarding multi-masters. Multiple masters, you can add that, or multiple control nodes. You can start using these commands also in the C. This is a command, you can use it, right? This is for our control planes. If you are trying to add control planes, you can use it. Similar way, if you are trying to add your worker nodes, you can use this command. So this is a unique key, you can see that. Unique token, you can see that. So worker node, you see. If you're trying to add any number of worker nodes, so you can start using this command. Okay. So in this way, you can start adding master node as well as worker nodes also. And also let us see other scenarios as well. Okay. So here we observed master node, worker node, pod network, and within the master node, different layers also we discussed. Also here we used container runtime containerd. Container runtime, you can use any container runtime, like you can use Docker, Podman, or containerd. Okay. Containerd, you can use it. Okay. So here there is a community called OCI, Open Container Initiative. Okay. Open Container Initiative. So with the help of this OCI, we can make sure whatever solution, different platforms you are onboarding, whether it is Docker or Podman or containerd, right? So here we can maintain compatibility also. So in this way, we can see basic scenarios related to our on-premises Kubernetes. So here we use kube-ADM mechanism. With the help of kube-ADM, we are trying to onboard our Kubernetes environment. Please see the documentation. If you like this video, please share it and see you in the next video.